Okay, next item is padding. Okay, it's also known as a zero padding. Okay, we already discussed about the stride there. If you remember, the first one already finished. Now we discuss about padding. So what is padding? In contrast with stride, okay, as you can see that stride, as well as by adjusting the stride which is more than one, or you can also use a pooling layer. Both have the same purpose, which is you want to shrink the matrix at the end side of the CNN architecture. Okay, that is where actually that is normal. That is very normal for CNN architecture, because it will start with the big matrix size as an input. So that's why, because the input is the image, and then it will keep shrinking towards to the end of the architectures. So in contrast with stride, padding is the purpose of padding is another way around, meaning that padding is where you the purpose of you apply padding is you want to maintain the size there. As you can see, this is the example of, you can see this picture is drawn in deep neural network architectures. It doesn't matter because it's similar to CNN. Okay, in order for you to produce the same output, the size of output, which is the size is similar to the input size, what you can do is that you apply the convolutional. If you in previous discussion, we don't consider padding, so that's why, as you can see, when we are discussing this part, this part, when you apply 4 times 4 matrix with 3 times 3, at the end you are if you assume the stride size is equal to 1, which is this one, at the end you will get only the output activation map is 2 times 2. Okay, it's 2 times 2, which is, this is the O number 7, this is O. Okay, just ignore this one because this is one from, this one is, this notation is from image processing class, so that's why you this one should be ignored. The output should be in this way. So it's a 2 times 2 matrix, which is, this is O7, this is O8, this is O number 12, yeah, and then this is O number 13. So 4 times 4 stride equal to 1. If you convolve with 3 times 3, this is what you get. Okay, 2 times 2. So in other words, even if you apply the stride equal to 1 by having this convolutional operation, now the output produced here is shrinking from the input, meaning the original size is 4 times 4, but at the end, after you apply this convolution, you only get 2 times 2. Of course, that is happen if you don't consider what we call as a padding. Okay, by having a padding, actually the main purpose of the padding, if you want to maintain the output size, meaning that, let's say if you have a 4 times 4 over here, but you want to have a output which is your O, or the output matrix is similar, which is still 4 times 4. Okay, you want to have a 4 times 4 at the activation map here. So in order for you to do that, that is where you apply a padding. So what is the meaning by padding? And in our class we refer to zero padding, is that you are enlarge the input image with 1 pixel size bigger. If you're talking about 3 times 3 filter, okay, if you're having a 3 times 3 filter and then you apply the padding, automatically the input size will enlarge with 1 line or 1 pixel line large as compared to original. And then because what we discuss here is a zero padding, it will put 0 over here. That is the meaning by zero padding. So by having a large input image here, you enlarge the image with 1 pixel line ahead, bigger as compared to the original size. If you apply this 3x3 matrix, then you for this application, then you must start over here, because this already 3x3. Okay, so that's why if you compute convolutional between this filter and this region, then you will get here, which is your, you can obtain your O1 over here, because you have a bigger size there. So at the end, you will get O1, you get O2, you get O3, you get O4. So you will get each and every O up until O, yeah, O19 over here, O19. So at the end, you can see that the activations map size is maintained 4x4, which is same size as your input matrix over here. So that is the main purpose of padding or zero padding, because the purpose is you want to maintain the input matrix with the same size as the, I'm sorry, the output. You want to maintain the output matrix size similar to the input matrix size. So means that your convolutionals does not affect, because the originally without padding, the convolutional operation will shrink your matrix. But in order for you to maintain the size of the output matrix, one way to do is by applying the zero padding. So the question is, or the issue is, why we need to maintain the matrix size? So the answer is, in general, you will see that, like what we have discussed in this architectures, one of the example of CNN architectures, yep, this one, you can see that, yes, you realize that it will keep shrinking. Okay, meaning that the matrix size, what I meaning by matrix size is just not the depth, because the depth, we just assume the depth will we don't discuss about the depth, we discuss about the size of X and Y. Okay, the X and Y of the matrix. Sorry, this is X, this is Y. Okay, in general it will shrink. Okay, we keep shrinking in that way up until you find out that it will only left a single pixels there, 1 times 1. That is the end point of your CNN, where it will decide whether represent the level of the image. So that's how the CNN looks like. But the tip is, in order for you to design CNN architecture, you should not shrink earlier. If you, I think if you refer to many well-known CNN architecture, they will first, sometimes they will maintain the size first. Okay, sometimes you will see in this shape, it will maintain the size, and then once they maintain the size, then they keep shrinking in that way. And sometimes they have many alternate operation, meaning that they maintain the size. Okay, I draw in this way because hopefully you can understand the what I try to draw here. Maintain the size, and then shrink a little bit, and then maintain the size, and then shrink a little bit, and then maintain the size before you fully shrink up until you get a single pixels there. Okay, so in order for you to maintain the size, this is where you need to apply the padding. Okay, at this position, at this position. Okay, at this position, or this position. So why we need to maintain the size? Why it's not appropriate to shrink earlier? That is because, in general, at the earlier stage here, there's a lot of information that cannot be you know, by depending on only one convolutional operation, you cannot have the filter where, again, if you remember that our objective is we want to find the coefficient of the filter, which is the W. So by having the convolutional at this point and this filter, I think in one convolutional layer you will have multiple filter over there. It's not enough for you to you know, apply the convolutional and then shrink, because if you shrink earlier, then there's a lot of information loss. So that's why you need to have several convolutional layer and that convolutional operation maintain the size before, because once you get the enough informations there, then you can shrink. Okay, so that is the reason, that is the some of the common sense that why we don't shrink the matrix earlier, because we don't want to lose information. So one way to do that is you need to apply several convolutional with pooling, by setting the pooling so that the output and the input size is similar, so meaning that we maintain the size. So the next process, you again apply the convolutional layer and then you maintain the size as well, so meaning that each convolutional operation will keep their own W and try to generate the good W to represent the meaningful information or the good features to be used for the end part. Because if you shrink earlier, then a lot of information lost, then the good feature is lost as well. So that's why in the tips is that at the earlier stage, please don't shrink earlier. Okay, this is also related to this thing. Yep, this one. Okay, as you can see, CNN, of course CNN is everything here. So at the earlier stage here, normally you are extracting a features. Okay, it's a feature extraction concept before you have a decision over here. So that's why at this earlier stage, normally people will not maintain, will not shrink the size, because we want to extract as much as possible as a good features to be used for decision making of around here. So that's why you need to maintain the pooling method is benefit in doing this thing. Okay, we will give a lot of benefit in doing this thing, because you don't want to lose information. Okay, so because again this is also related to the conventional machine learning. Okay, again remember, if you talk about the conventional machine learning, you must have one block FE, which is feature extraction, and then you have a decision or classification. Okay, before you can decide. So this is the way you apply the conventional machine learning here, but here you have human crafted feature extraction. So human crafted feature extraction, okay, that is how it's look like in convolutional machine learning algorithm. But when we go to the era of deep learning, everything here is have been integrated in one CNN. So that's why in nature, this first phase will do the feature extraction, while the second phase over here will do the decision. So that's why instead of you are shrinking this matrix, is not good for you, because you are by shrinking the matrix is also make the good feature loss. So that's why in general you need to maintain the matrix size, the input and the output must similar before you shrink at this level. Okay, so that is the overall concept or the reason why pooling is important. Okay, so back to the pooling discussion. Yep, so this is again the same things, but this one is example. This example show you in the deep neural network is not CNN, because it's look like everything is a fully connected layer there. Okay, this black dot here represent the pulling is a zero padding. Sorry, it's not pulling, a zero padding. You put 0 0 0. By putting a 0, it's like you are putting a dummy network there. You are just creating a dummy network, and then you apply the doesn't matter is it a convolution or matrix multiplication. So at the next stage, you find out the size is keep maintained, which is similar to the input size. For this output size around here is similar to this one. Output size around here is similar to the input size around here. So that is because of you are adding this dummy number here, dummy where is the value is 0. Okay, it's a 0. That's why they call it a zero padding. You put a 0 where actually that is your dummy numbers to maintain the size. So at the end, then you don't apply the padding. So by having a convolution or subsampling or maximum pulling layers, then it will keep shrinking in this second phase of the CNN. Okay, of course this is they draw it in this circle or neuron representation is not drawing in a matrix form. Okay, but if you draw in matrix form, it should be again we will not draw in this way. So in CNN in general we need to draw it in this way. Okay, yep, this way. Or where is it? Yeah, in this way. So in general, CNN is drawn in this way. Like I said in the earlier class there, in the earlier lectures, it should be drawn in this way. But this picture just want to show some idea about the padding. If you talk about the drawing the diagram in neuron form here, and the neuron representation here, so having the dummy neuron here, which is represent the 0 padding, then you can maintain the size there. From this stage into this stage into this stage, you maintain the size. Okay, so this is an example of 0 padding. As you can see that again we talk about our input matrix, which is 7 times 7. We ignore the depth size. Then we have a 3 times 3 filter, and then this 3 times 3 filter, the stride is equal to 1, and then you have a padding with 1 pixel border, meaning that you put a 0 0. I already discussed in the previous example. So at the end, the output size is still maintained 7 times 7 because you are at a dummies. You enlarge the matrix with 1 line pixels there, and then you put it 0 0, which is considered as a dummy numbers there. And after you apply the convolutional, then the output is 7 times 7, which is similar to the original size of your input matrix, which is 7 times 7. So again, this is the formula to find out the output size. Okay, you must consider the input size and then the filter size and the number of stride. Okay, this is the previous formula that we discussed before. So this is the actually okay, you can see that this is the automatic way to set the paddings there. Okay, like I said before, if your filter size is 3 times 3, then the 0 padding must with 1 line pixel size. Okay, because you when you apply the convolutional, the objective is that if you filter is 3 times 3, still you want to start your convolutional at this first pixel over here. So if you apply the 3 times 3 filter size, then you must enlarge your input size with 1 pixel line. So that is the way, that is one way, that is the only way that you can make it start at this position. So if you set your filter size with 5 times 5, in order for you to start here, then you must add another line here. Okay, must add another line. So that's mean, okay, another line here. So that's mean if you using the filter with size 5 times 5, then your zero padding must 2 lines of pixels border here. Okay, you must enlarge your input with 2 pixels border. So if you consider 7 times 7 filter, then you need to set your padding width, or you must enlarge your input matrix with 3 pixels border. So that is how it look like. Actually, it's automatically. Later you will see that in programming, when you doesn't matter you set 3, it must be 1. If you set 5, it must be 2. If you set the filter size 7, then the padding must be 3. Okay, it's already fixed inside the algorithm. You cannot change it, because that is how actually when you want to maintain if the objective is you want to maintain the size of the matrix, means that the output, if you want to the output matrix size similar to the input matrix size, then you must this one will be automatically generated by the algorithm, meaning that if you apply the filter size 3 times 3, it will use the zero padding with 1, and then filter size 5 times 5, the zero padding is equal to 2. Okay. So you can see that this is the formula to find out this one. Actually, without this formula also, you know that 3, if you 3, then you set into this formula, is equal to 1. If f equal to 5, you put in this formula, it's equal to 2. That's how we estimate how much zero padding need to be add up into your input matrix. Okay, it depend on the filter size. Okay, now let's take a look at these examples. Okay, so if you have the input size, which is 32, input matrix which is 32 times 32 times 3, again this is your depth size. Okay, depth size, and then you want to apply the convolution, you want to apply the convolutional layer, where in your convolutional layer, just assume this is where the convolutional layer is, where actually the convolutional layer consists of 10th number of filter with size 5 times 5, and then your stride is equal to 1, your padding is equal to 2. Of course, you can see that this 2 here, if this is 2, then of course 5 times 5, so if you apply 2 and stride is equal to 1, what will happen? It will automatically maintain the size. Okay, meaning that if the input here is 32 times 32, and then you don't jump more than 1, at the same time you are increase the padding 2 lines, 2 pixels, 2 pixels border. Okay, so by having 5 times 5, meaning that the output here, the volume should be what? Should be, this one is 32 and this one is 32. How about the depth size? What is the number of depth size there? Can you get it? What is the depth size? This one is 3, but here you have 10th which filter size. Okay, what is the meaning by here is that you have a 10 set of filter, which is 5 times 5 times 3. Okay, this one by default will follow this size. the size of this one. So that's why it should be 5 times 5 times 3. So at the end, what is the volume of, or the output size of, what is the matrix size of this output matrix? Okay, it should be 32 times 32 because of stride equal to 1 and padding equal to 2. By having a 5 times 5 filter, you have maintained the size, meaning that 32 going 32, 32 going 32. How about the depth? The depth should be equal to 10. Why is 10? The one should be equal to 10. Because you have 10 set of filter. Remember that one filter will produce only one layer. If you have 10 filter, you will have a 10 layers. So that layers represent your depth of your outputs matrix. Okay, this is just like exercise to you. Just review on the previous lecture if you remember about the layers there. Yep, this one. Okay, one filter. Okay, again that is depth size. You apply, you only get this one. Okay, in this case, because you don't apply the padding yet, so that's why you're not maintaining the size. That's why 28 times 228. But the convolution operation between this image and single filter 5 times 5 times 3, you get only this layer of the matrix, the first layer of the matrix. Okay, let's imagine if you have a second filter, the green one, then you produce another layers. So this is only for second. How about 10 filter of 5 times 5 times 3? So you will end up with 28 times 28. Okay, in this case is 28 times 28 times 10. So that's why in this example, in this exercise over here, okay, the depth size is 10 because the number of filter you use in this convolutional operation is 10. Okay, I hope you get what I mean. And the size is maintained because of this stride equal to 1 and the padding equal to 2. Okay, so that's how it's look like in order for you to estimate the volume size. Okay, how about calculate the, okay, it's 10 times 10. That is the volume size or the matrix size of the output image. And then how to calculate the number of parameter in this layer. So okay, calculate the number of parameter. The parameter here means that the question asks you to count how much, okay, how much the number of W as well as B. Okay, the W and B, the wake and the bias that involved in this convolutional layer. So in order to calculate that, then you need to calculate the size of the filter, because one filter you have 5 times 5 times 3, meaning the filter coefficient is 5 times 5 times 3. So this is where the total W that you have for one filter, and then this plus one bias over here. Okay, then one filter you have 76 parameter, and then since we have 10 number of filter, you must multiply this 76 with 10, then you get 760 parameter. So again, we can consider this one as small as compared to deep neural network. If you talk about deep neural network, because you don't have any shared parameter, each network have their each connection have their own W, then you will have more and more W if you talk about matrix multiplication. So that's why they change it. Instead of applying the matrix multiplication of fully connected layer, they apply the convolutional layer where it will reduce the number of parameters there. Okay, that is one of the reason why convolutional is applied and replacing the fully connected layer or matrix multiplication operation. Okay, the size of W is very small. Okay, so this is just a summarization in order for you to estimate the output volume or the output size matrix based on filter size. Okay, K here is a number of filter, and then F here is a filter size, S here is a stride number, and then this one is paddings. How much the padding is it? Is it 1 pixel border? Is it a 2 pixel border? Is it a 3 pixel border? And then you can estimate your output volumes there. Okay, don't worry, later we will have another discussion about another example exercise that hopefully that you can understand the mathematical operation behind it. Okay, it's not so tough as compared to the A and N that we learned before, because we just want to estimate the volume and then how to apply the convolutional operation. After apply the convolutional operation, what is the output that you get? So that is the things that we will discuss. And again, like I said in the earliest lecture, we will not emphasize on the backpropagation. Even actually backpropagation happen at the CNN, but we don't discuss that anymore, because the operational of backpropagation in CNN is similar to the A and N, but we cannot do the derivation because the matrix size is too big, so it's very complicated to be discussed by hands-on. So because you already have some skill in derive the neural network for the simple A and N, so actually that is the fundamentals. Fundamentally you are prepared in understanding this CNN because you already done it in A and N, so it's similar. Okay, so for this slide you can read for yourself, because this one is the same thing. We just discussing about by having vary all the parameters. So can you estimate the number of the input, the size of the output matrix there. Okay.